just looking at the picture here, we're going to just list alternate interior angle pairs. They come in pairs like yesterday, like vertical angles. So what that means, here's a transversal. That's this blue line. Alternate interior angles would be angles that are on alternate sides of the transversal. So one would be on the left and one would be on the right, but in between the parallel lines. That's why it's interior. So they're like, if I look at 4, that's in between the green lines. And the other angle that's in between the green lines, but on the other side of the transversal is 6. So angles 4 and 6 form a pair of alternate interior angles. Okay? So what's another set, Nadeem?
5 and 3, but what about 4?
Okay, 5 and 3 are the other pair. So 4 and 3, that was yesterday. They form a line. We call that a linear pair. So we can, those are supplementary, remember that from yesterday? So that's a linear pair. So angle 4 and angle 3 would be a linear pair. Angle 4 and angle 1, angle 3 and angle 2, angle, no. So angle 3 and 6, that's called consecutive interiors. We're not going to do all of them because the key ones for you to know are basically linear pairs, alternate interior, vertical, and corresponding. Just so you get used to that vocabulary. There's lots of names, but those are the keys. Okay. So what was another linear pair?
5 and 6.
5 and 6.
6 and 7.
6 and 7. Right, there's a bunch of them.
5 and 8.
5 and 8.
8 and 7.
And 7 and 8, right?
8 and 7 is 4.
Yeah, and I missed one, right? Angle 1 and 2. Okay, so linear pairs, the key is they sum to what? 180. That's the key to linear pairs, is that they sum to 180 degrees. Okay. They're not only adjacent, but they form a line. Okay?
Oh, yeah.
So we want to kind of focus on alternate interiors for a minute. So this is one set. The other set would, the other type of angles are corresponding. Can't get there. Okay, good questions. So corresponding would be on the same side of the transversal in the same relative position. So both above parallel lines or both below. So like 2 and 6, that's one set of corresponding angles.
So like 8 and 4.
8 and 4, because they're both below and on the left side of the transversal.
And 7 and 5. 5 and 1.
7 and 3 would be a set of corresponding.
5 and 5. 4 and 8.
And 5 and 1.
4 and 8. She already has that. You can find it. Oh, if you just add 4 and 8.
The way I numbered them, yeah. Okay, so the one Nadeem asked about, 2 and 8, well, they name most everything. They're alternates because they're on opposite sides of the transversal, and they're exterior because they're outside of the green lines. But just looking at those pairs over there, if you have parallel lines, Sean, question?
Because linear pairs sum to 180.
Right.
On the number 6 problem on the whole.
Okay, let's do this first. I want to finish this, and then we can look at the homework. Okay? Because we didn't get to that yesterday because of not having a chance to talk about it, but this leads into that. So we could start with the idea, like, because linear pairs, like 1 and 2 are supplementary, and we know 2 and 4 are equal, what do we know? Were you going to ask something about that, or?
No, I was going to say, wouldn't that be how you solved it? Because on number 6, the 4x minus 2
Yeah, we'll go to that in a minute. It's too many like things at once, but we will come to it. It's a good question. So what we did look at yesterday that I want you to take a quick look at today is if I took a highlighter and looked at any one pair of alternate interior angles, like 4 and 6. What I should know is that if I took that and just flipped it around, what do we know about 4 and 6? They're the same. That's only true when the lines are parallel. Because imagine if that green line wasn't parallel and it went like this, right? In other words, if I had a different picture, let me draw a better picture of that. If I had a situation where I had two lines that were not parallel and a transversal, and I numbered it still the same way, 1 and 2, 3, 4, 5, 6, 7, 8. 4 and 6 are still alternate interior angles in this picture, but they're not the same. Because 4 is bigger than 90 degrees. The 6 looks like it's, a little bit bigger, but not as big. So like if I trace 4 and the lines are not parallel, just with the tracing, you can see that it's not the same as 6. You see that? So alternate interior angles are equal when what is true? Only when the lines are parallel, right?
It's like 2 and 8 be an alternate exterior angle?
2 and 8 would be an alternate exterior angle. So you're focusing on parallel lines today, okay? So maybe that's the note you want to write. Alternate interior angles are equal when the lines are parallel, right? That's the key. Does that make sense? So what about corresponding angles? Yeah, it's going to be because what's a corresponding angle to 6? 2, right? So if I just take this and flip it, that was the same as 6, right? Corresponding angles are equal. Ian, a couple more minutes. So this statement over here is true. Look at my big arrow, they turned into a U. Martinis? What? When?
You are equal when martinis.
That's so funny. That's going to be really loud. Okay, that's so funny. Howie got that out of my printing.
We are equal to the martinis.
What is lines? When the lines are parallel? Isn't that funny?
You are equal when the martinis.
Yeah, I don't know. Every once in a while, you guys, it just does weird things, right? It's on the recording.
Are you gonna cut this out?
No. That's funny. Those are the only things that keep you guys going sometimes, are the mistakes. Right? So all of these are equal when the lines are parallel. Are we good on that? Okay. Yes or no? Do you understand that?
Yes.
Let's go to Sean's question. We'll take a few questions first. Emilio. Okay, Matthew.
Well, does that mean that angle 1 and angle 7 are alternate exterior?
And they would be equal too, wouldn't they?
Yeah.
Right. Because when you have parallel lines, alternate exteriors are going to be equal to, for the same reason, So I could take that and rotate it. And you get into much more detail about this when you do geometry. That's why we're not doing all the formal language, just a little bit of formal language. So if we look at that worksheet and go to, let's bring this page up here and look at the question I think Sean was trying to ask was with the problem down here, right?
Yeah.
And so somehow this got a little put together funny. Okay, so now we have this picture here. What we know is that vertical angles are what? What do we know about vertical angles? They're equal, right? So I could mark these equal. That's how I would do that, right? And so then I would know that alternate interior angles are equal. So now these two are equal, right? Well, and I know that this angle here has to add up with this angle here to be how much? 180. So since the one marked in red is the same as this, I can just say that this is like that. And that brings us up to the problem like we did yesterday, right? When they form a line, these are supplementary, right? So you add them, right? So you just add them. You're going to say 4x take away 2 plus 3x plus 7 equals 180.
Which equals 7x minus 5. No, plus 5.
Well, let's think about that. 7x, right, is correct because you take the sign in front, so 7x. And then you're right, you're going to have a negative 2 and a positive 7, so that's a positive 5 equals 180. So subtract 5. 175. Yeah, I didn't make very nice numbers on this, did I? I should have, but I didn't. It's good for you, though. 7 goes into 17 how many times? Twice, right?
25.
Oh, I did mess numbers. Because 7 goes into 17 twice, 2 short division, what's the remainder? 3. 7 into 35? 5. So x is 25. Emilio. Down here? Okay, so what I did was, I know it wasn't originally there, but with my lines and the rules, we know that alternate interior angles of parallel lines are equal. So I'm saying these two are equal. And vertical angles are equal. So that means I could make this 3x plus 7. So those markers all mean they're the same. Yeah, but I don't need to. So I don't want to make it harder than it is. But you're right. So over here, again, this little picture got, was this out here?
Yeah.
So these are corresponding angles. So if you remember the rule, corresponding angles are equal. But you could always, so in other words, that's the rule for this side here, right? The corresponding angles are equal. Does that make sense? But you could also just use your knowledge of vertical angles and alternate interior angles, because this angle here is the same as this, right? And these are alternate interior, so they're equal. So they're the same. So I can set 3x minus 15
Equals 2x.
Yes. So subtract 2x and add 15. So you get 1x cancel, cancel 25. Ah, X is 25 on both of them. How about that? Okay. So for the remaining class time, you're going to start an activity, but you're not going to finish it. Now there's some vocab you might not know in the activity. It's a matching activity, the different matching cards that we've done. I'm just going to show you, like these cards. See them? There's a bunch of cards, but you can see some of them are like, this is like what we were just talking about. So you're going to work out the problem on this side and find the answer on the next card. So the answers are here, right? These are clearly not parallel segments. You work out the problem on the right and you match it to the card that has the answer on the left. Remember doing those?
Yeah.
And there's all kinds of like geometry things in here. Surface area, nets, right angles. So you just are going to have to work in groups of threes.